Did you know that Voyager 1 is currently traveling at 38,000 miles per hour through interstellar space, yet it would still take over 73,000 years to reach the nearest star? This incredible spacecraft has been humanity's most distant messenger for decades, sending back data from the edge of our solar system, where no human-made object has ever ventured before. But here's the mind-blowing part. It just detected something moving out there that's completely rewriting the rules of space exploration. Do you know what could possibly be lurking in the cosmic void that caught Voyager's attention? The mysterious detection. What if I told you that humanity's most distant messenger just stumbled upon something that's rewriting the rules of space exploration? Voyager's instruments suddenly lit up like a Christmas tree when they detected an anomalous signal showing something in motion far beyond our solar system's boundaries. This wasn't your typical space rock drifting aimlessly through the void. The object wasn't following any predictable orbital pattern that planets are known for, and its movement seemed almost deliberately erratic. Scientists initially dismissed it as a potential glitch in the decades-old equipment, but when multiple readings kept confirming the same impossible data, they realized something extraordinary was actually out there. The object appeared to be moving in ways that completely defied conventional astronomical expectations, accelerating and decelerating at seemingly random intervals, as if it possessed some form of intelligence or control system. What made this discovery even more mind-bending was that the movement patterns were so unusual that astronomers had to throw out their existing tracking models and create entirely new ones just to follow its trajectory through the cosmic darkness. The readings suggested this mysterious entity was operating under principles that our current understanding of physics couldn't easily explain, leaving the scientific community both thrilled and deeply unsettled by the implications of what Voyager had accidentally discovered in the furthest reaches of known space. Beyond planetary motion. You know what separates a wandering space rock from something that might actually be intelligent? The way it moves? This wasn't your typical celestial body behavior that astronomers study in textbooks. We're talking about something that completely broke the fundamental rules of how objects are supposed to move through space. While planets follow those predictable elliptical orbits around stars that we've mapped for centuries, this mysterious object was dancing to its own cosmic rhythm, moving in patterns that seemed to mock our understanding of orbital mechanics. The really spine-chilling part? It appeared to accelerate and decelerate at what seemed like random intervals, almost as if something was making conscious decisions about where to go next. Scientists watching the data streams felt like they were observing a chess player making calculated moves, rather than a lifeless chunk of matter drifting through the void. The movement patterns were so fundamentally different from anything in our astronomical databases that researchers had to abandon decades of established tracking protocols and develop completely new mathematical models just to predict where this thing might go next. What kept everyone awake at night was the unsettling realization that this object seemed to possess some form of propulsion or guidance system that operated independently of any known gravitational influences, suggesting either revolutionary physics at work or something far more extraordinary than anyone was prepared to admit publicly. Instrument readings gone wild. When a machine built in the 1970s starts detecting signals that don't exist in any modern database, you know something's seriously wrong. Voyager's magnetometer and plasma wave instruments began registering readings that sent shock waves through mission control, displaying data patterns that didn't match a single entry in their comprehensive astronomical databases. The object appeared to be generating its own electromagnetic field, which is incredibly rare for natural space objects and typically only seen in active stars or massive planetary bodies with molten cores. Even more bizarre, the readings suggested this mysterious entity might be rotating or tumbling in a highly complex pattern that created interference signatures unlike anything scientists had previously encountered from asteroids, comets, or typical space debris. The electromagnetic emissions were so unusual that they seemed to pulse in rhythmic intervals, almost like a heartbeat echoing through the vacuum of space. What made the situation even more unsettling was that these readings were coming from instruments that had been functioning flawlessly for decades, suddenly encountering phenomena that their creators never anticipated when designing the detection systems back on Earth. The data streams showed energy signatures that fluctuated in ways that suggested either some form of internal power source or an interaction with unknown cosmic forces that current physics couldn't adequately explain. mission scientists found themselves staring at computer screens, displaying information that challenged everything they thought they knew about how objects behave in the cold emptiness of interstellar space, leaving them questioning whether they were witnessing a natural phenomenon or something far more extraordinary. The rogue object theory. So, what happens when scientists discover something that's, too small to be a planet but way too active to be just dead rock? Well, at first scientists thought maybe this could be a rogue planet, one of those lonely worlds that gets ejected from its original solar system and ends up wandering through the infinite darkness of interstellar space, sort of like a cosmic exile. These planetary outcasts are known to drift aimlessly through the void after getting gravitationally kicked out of their home systems by larger planets or big stellar events. But the size readings from Voyager's instruments just didn't match up with what you'd expect from a typical rogue planet. And even more puzzling, rogue planets don't usually move with such unpredictable and honestly almost purposeful patterns. They tend to follow predictable trajectories influenced by the gravitational pull of nearby massive objects. But this mysterious entity seemed too small to qualify as a planet, yet it was far too large and energetically active to be classified as your typical space debris or asteroid material floating through the cosmic wasteland. What really threw researchers off was the object's apparent ability to change direction and speed without any obvious external gravitational influences acting on it. That kind of behavior totally contradicted everything scientists thought they knew about how rogue planets should behave out in the emptiness between star systems. The data pointed to something that existed in this strange middle ground between planetary and non-planetary classifications, leaving the scientific community with, way more questions than answers about its true nature and origin. This discovery really forced astronomers to rethink their basic understanding of what makes a planetary body, and whether there might be entirely new categories of cosmic objects drifting through space that just don't fit into our current classification systems. Artificial origin speculation. The moment scientists started whispering about artificial intelligence in deep space, everything changed. Here's where the discovery really took a turn, and made even the most skeptical researchers pause and rethink everything they thought they knew about our cosmic neighborhood. Some scientists began seriously wondering if this mysterious object could actually be artificial in origin, a possibility that sent ripples of both excitement and, honestly, a bit of terror through the astronomical community. The object's highly unusual movement patterns, those distinctive electromagnetic signatures, and its apparent ability to change direction without any obvious external forces, led to these hushed conversations about possible extraterrestrial technology drifting out there in the void. Now, while most established researchers stayed publicly skeptical and didn't want to jump to such extraordinary conclusions, the data piling up was compelling enough that even the most conservative astronomers couldn't completely dismiss the possibility of an artificial probe or spacecraft from another civilization. What made this theory so unsettling was that the object seemed to actually show behaviors that matched up with some kind of guidance system or onboard intelligence, responding to unknown stimuli in ways that natural space objects just don't. The electromagnetic pulses appeared almost like communication attempts or maybe diagnostic signals, suggesting internal systems that could be actively monitoring or scanning the surrounding space environment. All this speculation opened up some mind-bending questions about whether humanity had just stumbled across evidence of advanced alien technology, possibly an automated probe sent by a distant civilization to explore our neck of the galaxy. That would fundamentally challenge our understanding of whether we're truly alone in the universe, and what other intelligences might be silently watching us from the darkness of space. Comet or something else? So, when something behaves like a comet but breaks just about every rule about how comets are supposed to work, you've really got a cosmic mystery on your hands. The next theory that popped up from all the scientific chaos focused on whether this enigmatic object could some kind of unusual comet with a highly irregular orbit. But even this seemingly logical explanation started to fall apart under closer scrutiny. Comets are notorious for their unpredictable behavior, especially when they interact with solar winds and the gravitational fields from massive celestial bodies. That's what creates those spectacular tails and erratic flight paths that can confuse even the most experienced astronomers. However, this mysterious object was positioned way too far from any star to show the typical comet behavior that scientists have documented for centuries. It was operating in the cold vacuum of interstellar space, where solar radiation really shouldn't have much impact on its structure or movement patterns. What made the comet theory even more unlikely was that the object's movement seemed totally independent of any detectable gravitational influence from nearby stellar bodies. That kind of thing suggests it had some form of internal propulsion system, rather than just relying on external cosmic forces. Traditional comets follow predictable physics when they get close to heat sources, developing those characteristic tails and accelerating in ways that match established mathematical models. But this object just didn't fit those expectations at all. The electromagnetic readings and those weird directional changes happened without any connection to solar activity or gravitational wells, which indicated that whatever this thing was, it operated under principles that had nothing to do with the usual ice and rock composition that defines comets. That left researchers seriously wondering if they were dealing with something that was just pretending to be a familiar cosmic phenomenon. Interstellar visitor analysis. Sometimes, the most terrifying discoveries are the ones that remind us we're not alone in this cosmic neighborhood. Data analysis revealed this object might be an interstellar visitor, something that originated outside our solar system and was just passing through our cosmic backyard like an uninvited guest. Similar to Oumuamua, the mysterious cigar-shaped object that briefly visited us back in 2017 and left scientists scrambling for explanations, this new detection showed unmistakable characteristics of something that definitely didn't belong to our familiar solar system family. However, unlike Oumuamua, which seemed to drift through space following predictable physics, this object appeared to be actively maneuvering rather than just coasting on momentum from its original trajectory. The spectral analysis suggested it carried chemical signatures completely foreign to anything found in our local planetary formation, indicating it had traveled unimaginable distances through the void between star systems before somehow ending up in Voyager's detection range. What made this discovery particularly spine-chilling was the realization that if this was indeed an interstellar traveler, it meant our solar system was being visited by objects from distant cosmic regions, with potentially different physical laws or evolutionary histories. The object's ability to maintain apparent control over its movement after what must have been millions of years of interstellar travel suggested either incredibly advanced preservation technology or something that, honestly, challenged our understanding of how matter behaves across vast cosmic distances. This raised unsettling questions about what other mysterious visitors might be silently passing through our solar system without our knowledge, observing us from the darkness. Scientific community divided. Nothing splits the scientific world faster than a discovery that challenges everything we thought we knew about reality. The discovery created a massive rift that split the scientific community into warring factions, each defending their interpretation of the data with the passion of religious zealots. Conservative astronomers dug in their heels, insisting this must be a natural phenomenon they simply hadn't encountered before, arguing that extraordinary claims require extraordinary evidence and that jumping to wild conclusions would damage their professional credibility. Meanwhile, a growing faction of researchers argued that the mounting evidence pointed to something far more extraordinary than conventional wisdom could accept, suggesting that clinging to outdated assumptions was preventing genuine scientific progress. Peer review processes transformed into heated battlegrounds where respected colleagues found themselves shouting across conference rooms, with researchers demanding more comprehensive data before making any definitive conclusions about the object's true nature and origin. The tension became so intense that some scientists refused to collaborate with colleagues who held opposing views, creating an unprecedented schism in a field that typically thrives on cooperative research and shared discoveries. What made this division particularly bitter was that both sides were working with the same limited dataset from Voyager's aging instruments, yet reaching completely different conclusions about what they were observing in the depths of space. The controversy exposed deep philosophical differences about how science should approach unexplained phenomena, with traditionalists advocating caution, while progressives pushed for bold new theories that could revolutionize our understanding of the cosmos and humanity's place within it. Technology limitations. When your most advanced space probe is running on technology older than most smartphones, getting answers becomes nearly impossible. Unfortunately, Voyager's aging instruments and vast distance from Earth meant the data was frustratingly limited and sometimes contradictory, like trying to solve a murder mystery with a broken magnifying glass. The spacecraft's communication systems, originally designed in the 1970s using technology that would seem primitive compared to a modern calculator, struggled desperately to transmit detailed information about this unprecedented discovery across the mind-boggling distances of interstellar space. Scientists found themselves in the maddening position of having to work with incomplete datasets that arrived months after being recorded, making it incredibly challenging to determine exactly what Voyager had encountered in the cosmic depths. The probe's instruments were never designed to analyze the type of anomalous readings they were now detecting, forcing researchers to extrapolate conclusions from equipment that was already operating far beyond its intended lifespan and capabilities. Signal degradation across billions of miles meant that crucial details about the object's behavior were lost in transmission, leaving tantalizing gaps in the data that could have provided definitive answers about its nature and origin. What made this situation even more frustrating was that by the time scientists received and analyzed the information, the mysterious object had often moved to a completely different location, making follow-up observations nearly impossible. The technological limitations created a perfect storm of scientific frustration, where humanity's most distant explorer had discovered something potentially revolutionary, but lacked the tools to properly study it. Ongoing mystery. Some mysteries are so profound that they redefine what we thought was possible in the universe. As of now, the object remains one of space exploration's greatest unsolved mysteries, a cosmic riddle that continues to haunt scientists and challenge our fundamental understanding of what exists in the vast emptiness between stars. Voyager continues to track its movement when possible, but the object's unpredictable behavior makes consistent observation feel like trying to photograph a ghost that appears and disappears at will. The enigmatic entity seems to operate under its own mysterious agenda, sometimes vanishing from detection for weeks before reappearing in completely unexpected locations, as if it's deliberately evading our attempts to study it. Future deep space missions are being frantically planned with more advanced instruments specifically designed to investigate similar anomalies, but the reality is that we're still years away from having the technology capable of properly analyzing whatever this thing actually is. For now, we're left in the uncomfortable position of knowing something extraordinary is out there, moving through the cosmic void with apparent intelligence or purpose, while being completely powerless to determine its true nature or intentions. The discovery has fundamentally altered how scientists approach the search for unusual phenomena in space, forcing them to acknowledge that our universe might be far stranger and more populated than we ever dared to imagine. This mysterious object serves as a humbling reminder that despite all our technological advances and scientific achievements, we're still cosmic children stumbling around in the dark, occasionally bumping into things that shouldn't exist according to our current understanding of reality. So what do you think we're dealing with here? A natural phenomenon we've never encountered before, or something that challenges our understanding of what's possible in deep space? The fact that Voyager can still surprise us with discoveries like this just shows how much we still don't know about our universe. Drop a comment below and let me know your theory about this mysterious moving object. I read every single one. If this blew your mind, smash that subscribe button and hit the bell icon so you never miss when Space Facts drops new content. Until next time, keep looking up. On September 26, 2022, NASA's DART mission slammed into asteroid Dimorphos, shortening its orbit by 32 minutes, a jaw-dropping 26 times the shift scientists predicted. We didn't merely tap a space rock, we rewrote the playbook on planetary defense in a single, spectacular collision. Earth just proved it can shove mountains in the vacuum of space. Will we do it again when everything's on the line? Did you know one well-aimed kinetic strike could steer a city-killer asteroid clear of our planet? The DART mission. Space debris just became humanity's new superpower. What started as NASA's most ambitious planetary defense experiment turned into the discovery that could save our planet from extinction. On September 26, 2022, the DART spacecraft slammed into asteroid Dimorphos at breakneck speed, traveling 370 million kilometers from Earth to execute what many called humanity's first real-life superhero moment. But here's where everything went beautifully wrong. instead of the predicted tiny 73-second orbital shift. Something absolutely mind-blowing happened that left scientists speechless and completely rewrote the rules of planetary defense. The double asteroid redirection test wasn't just about proving we could hit a cosmic rock the size of a football stadium. This was our species taking its first serious swing at playing cosmic billiards, testing whether we could actually nudge a potentially dangerous asteroid off course before it ruins everyone's day. Launched back in November 2021, DART had one job: crash into Dimorphos, the smaller moon orbiting the larger asteroid Didymos, and see what happens when human engineering meets ancient space rock. Scientists expected a gentle nudge, a small proof of concept that might buy us some confidence for future planetary threats. What they got instead was a masterclass in cosmic physics that exceeded their wildest calculations and fundamentally changed how we think about defending Earth from asteroid impacts. Impact results analysis. The cosmic equivalent of hitting a home run when you were just trying to bunt. When the dust literally settled after DART's kamikaze mission, astronomers pointing their telescopes at Dimorphos couldn't believe what they were seeing. The Hubble Space Telescope and ground-based observatories worldwide detected something that made every planetary scientist do a double-take. This wasn't the gentle tap they had modeled in their computers. The asteroid's orbital period had shifted by an astronomical 32 minutes, not the modest 73 seconds they had predicted. That's like expecting to move a boulder an inch and accidentally launching it across the parking lot. But here's where the real detective work began. The impact results analysis revealed that Dimorphos had essentially turned into a temporary comet, spewing out a massive debris plume that acted like a natural rocket engine. This wasn't just impact physics. This was discovering that asteroids could become their own propulsion systems when hit just right. The momentum transfer was 26 times greater than expected, meaning NASA had accidentally stumbled upon a planetary defense cheat code. Scientists frantically recalculated everything they thought they knew about asteroid deflection, realizing that a relatively small spacecraft could potentially redirect city-destroying space rocks with far less effort than anyone had dared hope. The implications were staggering. Humanity's cosmic insurance policy had just gotten a massive upgrade, and all it took was one perfectly executed space crash. Momentum enhancement discovery. Sometimes the most incredible discoveries happen when your experiment works too well. The momentum enhancement discovery from DART's impact wasn't just a pleasant surprise, it was a complete game-changer that sent shockwaves through the planetary defense community. When scientists analyzed why Dimorphos got knocked around like a cosmic pinball instead of just gently nudged, they uncovered physics that Hollywood couldn't have written better. The secret ingredient? That spectacular debris cloud wasn't just pretty space fireworks, it was functioning as an improvised rocket engine, blasting material away from the asteroid and creating additional thrust that multiplied the deflection effect beyond anyone's wildest dreams. This momentum enhancement effect revealed something extraordinary about how kinetic impactors actually work in the real universe versus computer simulations. The ejected debris acted like exhaust from a rocket, pushing Dimorphos in the opposite direction with tremendous additional force. It's like throwing a baseball and having it somehow gain speed mid-flight. Completely counterintuitive but absolutely real. The 26-fold multiplication of expected results meant that future planetary defense missions could potentially redirect dangerous asteroids using much smaller spacecraft than previously thought necessary. Scientists realized they had witnessed something that could revolutionize how humanity approaches asteroid threats. Instead of needing massive, expensive missions to deflect city-killer asteroids, relatively modest spacecraft could potentially do the job thanks to this newly discovered physics phenomenon. The universe had just handed humanity a cosmic cheat code for planetary defense, wrapped up in the most successful space crash in history. Asteroid structure insights. Some asteroids are basically cosmic sandcastles waiting to fall apart. The asteroid structure insights from DART's encounter with Dimorphos completely shattered our assumptions about what these space rocks are actually made of. When mission scientists dove deep into analyzing why the impact was so devastatingly effective, they discovered that Dimorphos wasn't the solid, monolithic boulder they had expected. It was what researchers now call a rubble pile, essentially a loose collection of rocks, dust, and debris held together by nothing more than weak gravitational forces. This revelation explained everything about the spectacular 32-minute orbital change and why the debris plume was so massive. Think of it like the difference between hitting a concrete wall versus a pile of gravel. The energy transfer is completely different. When DART slammed into this cosmic rubble pile, it didn't just create a neat crater like punching solid rock. Instead, it excavated enormous amounts of material, launching chunks of Dimorphos into space and creating that dramatic comet-like tail that telescopes tracked for weeks. This discovery fundamentally changed how scientists classify near-Earth asteroids and assess potential planetary threats. The loose structure meant that kinetic impacts could be incredibly effective against similar rubble pile asteroids, potentially making planetary defense missions far more successful than anyone had dared hope. But it also raised new questions. How many potentially dangerous asteroids share this loose, fragmented structure? The answer could determine whether future deflection missions are routine procedures or complex engineering challenges requiring completely different approaches. Strategic implications. One successful space crash just upgraded humanity's survival odds by millions. The strategic implications of DART's overwhelming success rippled through every space agency and planetary defense program on Earth, fundamentally reshaping how we approach the cosmic threat of asteroid impacts. When the momentum enhancement discovery proved that deflecting dangerous asteroids could be 26 times easier than previously calculated, it wasn't just a scientific breakthrough. It was a species-level game-changer that moved us from theoretical planetary defense to proven, practical capability. Military strategists, space engineers, and government officials suddenly realized that protecting Earth from city-killer asteroids might not require the massive, expensive missions they had been planning for decades. The implications extend far beyond just building bigger rockets or spending more money. This discovery means that relatively small, affordable spacecraft could potentially redirect near-Earth objects that pose existential threats to human civilization. Space agencies worldwide began recalculating their planetary defense budgets, realizing they could potentially defend against multiple asteroid threats with the same resources previously allocated for single missions. The kinetic impactor technique went from experimental concept to proven technology overnight, giving humanity its first real planetary defense weapon that actually works better than designed. But perhaps most importantly, the success demonstrated that we don't need decades of warning to mount an effective defense. The momentum enhancement effect means faster, more responsive missions could potentially handle threats detected with shorter lead times, dramatically improving our cosmic security posture. Hera mission planning. The real investigation starts now. While DART proved that humanity can successfully punch asteroids off course, the European Space Agency wasn't about to let this cosmic crime scene go unexamined. Enter Hera mission planning, the detective work that will finally reveal exactly what happened when our spacecraft obliterated Dimorphos, and why the results were so spectacularly beyond expectations. Scheduled to launch in 2024, this follow-up mission will arrive at the Didymos system in 2026 to conduct the most detailed forensic analysis of an asteroid impact in human history. Think of Hera as the cosmic CSI team, arriving to photograph the crater, measure the debris, and piece together every detail of humanity's first successful planetary defense demonstration. But Hera isn't just satisfying scientific curiosity, it's gathering critical intelligence for future planetary defense missions. The spacecraft will precisely measure Dimorphos's mass, analyze the crater's dimensions, study the asteroid's internal structure, and determine exactly how much material was ejected during impact. This data is absolutely crucial because the next time we need to deflect an asteroid, it won't be a test. It could be the difference between civilization and catastrophe. Hera's findings will help scientists understand whether the momentum enhancement effect was a lucky accident or a predictable phenomenon that can be reliably reproduced. Armed with this knowledge, future deflection missions can be planned with surgical precision, ensuring that when humanity faces a real cosmic threat, we'll know exactly how hard to hit it. Planetary defense evolution. From asteroid hunters to cosmic guardians in just one successful crash. The planetary defense evolution triggered by DART's triumph represents the most significant shift in humanity's approach to cosmic threats since we first started tracking near-Earth objects. Before September 2022, planetary defense was largely theoretical. Scientists could model asteroid impacts, calculate trajectories, and propose deflection strategies. but nobody actually knew if any of it would work when push came to shove. Now, with real data proving that kinetic impactors are devastatingly effective, space agencies worldwide are completely rewriting their threat assessment protocols and emergency response procedures. The momentum enhancement factor isn't just being incorporated into computer models, it's fundamentally changing how we categorize asteroid risks and allocate planetary defense resources. This evolution goes beyond just updating equations and mission plans. Countries that never had serious planetary defense programs are suddenly investing in asteroid detection networks and deflection capabilities. The International Space Station partners are collaborating on advanced warning systems, while private companies are developing rapid response spacecraft that could be deployed within months rather than years. The success has also accelerated development of next-generation asteroid hunting telescopes and improved orbital prediction algorithms. Most importantly, the psychological shift is enormous. Humanity has moved from passive observers of cosmic threats to active defenders of our planet. We're no longer just hoping that dangerous asteroids will miss us, we now have proven technology to make sure they do. The age of planetary defense isn't coming someday. It arrived the moment Dimorphos got knocked sideways by human ingenuity. Mission success redefinition. Success isn't always about hitting your target, sometimes it's about completely redefining what success means. Mission success redefinition became the most unexpected outcome of the entire DART program, fundamentally changing how space agencies measure achievement in planetary defense missions. Before impact, NASA had already declared the mission a triumph simply for demonstrating that humans could accurately navigate a spacecraft across 370 million kilometers and hit a target the size of a football stadium. The primary objective was purely technological: prove the guidance systems work, test the kinetic impactor concept, and measure any detectable change in Dimorphos's orbit, no matter how small. Mission planners would have celebrated even a 10-second orbital shift as groundbreaking proof of concept. But the universe had other plans. When the 32-minute orbital period change was confirmed, it didn't just exceed expectations, it obliterated every benchmark scientists had established for what constituted mission success. This wasn't incremental progress, it was a quantum leap that forced mission planners to completely recalibrate their success metrics for future planetary defense operations. The 26-fold enhancement over predicted results meant that DART had essentially accomplished what multiple missions were designed to achieve. Space agencies worldwide began questioning whether their own success criteria were too conservative, whether they were underestimating human technological capabilities, and how to properly set goals for missions venturing into uncharted scientific territory. The redefinition cascaded through every future mission proposal, with engineers now expected to plan for spectacular success rather than modest achievement. Debris management and safety concerns. What happens when your successful space mission accidentally creates a cosmic mess? The debris management and safety concerns following DART's spectacular impact revealed that planetary defense isn't just about hitting asteroids, it's about dealing with the aftermath of turning space rocks into temporary comets. When Dimorphos got walloped on September 26, 2022, it didn't just change its orbit, it transformed into a debris-spewing machine that kept astronomers busy for months tracking every chunk of ejected material. Ground-based observatories worldwide suddenly found themselves monitoring a massive cloud of asteroid fragments spreading through space, creating an unprecedented challenge in space situational awareness and collision risk assessment. The spectacular debris plume that made DART so successful also raised serious questions about future deflection missions near critical space infrastructure. The ejected material created a comet-like tail visible through telescopes for weeks, with chunks of Dimorphos scattered across thousands of kilometers of space. Mission controllers had to carefully track this debris field to ensure it posed no threat to other spacecraft operating in the region, while also studying its behavior to improve debris modeling for future planetary defense operations. This unexpected consequence highlighted a crucial gap in mission planning. While everyone focused on successfully deflecting the asteroid, nobody had fully anticipated the complexity of managing the resulting space debris. The lesson was clear. Future deflection missions targeting asteroids closer to Earth or near valuable satellites will need sophisticated debris mitigation strategies to prevent turning one cosmic threat into dozens of smaller ones. precision requirements for real threats. Practice makes perfect, but real asteroids don't give you second chances. The precision requirements for real threats expose the sobering reality behind DART's celebration-worthy success. While humanity proved we can deflect asteroids, the margin for error when facing actual Earth-threatening objects is absolutely zero. Unlike the controlled experiment with Dimorphos, where scientists had years to plan and could afford to overshoot their deflection goals, a genuine planetary defense scenario demands surgical precision that accounts for every variable imaginable. The momentum enhancement effect that made DART so spectacularly successful also introduced a new layer of complexity. Future deflection missions must accurately predict how much debris each target asteroid will eject, because the difference between nudging a space rock safely away and accidentally hurling it toward a populated area could determine the fate of millions. The challenge intensifies when considering that every potentially hazardous asteroid has unique characteristics that could dramatically affect deflection outcomes. Rubble pile asteroids like Dimorphos might respond completely differently than solid metallic objects, icy comets, or loosely bound dust clouds. Mission planners now face the daunting task of developing deflection strategies that work across this entire spectrum of cosmic threats, all while operating under the pressure that failure means catastrophic impact. The years of advance warning required for successful deflection means that asteroid detection networks must identify threats earlier and with greater accuracy than ever before. One miscalculation in trajectory, timing, or target composition could turn humanity's greatest technological achievement into its most devastating mistake. That's how NASA turned one perfectly executed space crash into humanity's greatest planetary defense breakthrough. The DART mission didn't just prove we can protect Earth from asteroid threats, it showed us we're way better at cosmic billiards than anyone dared hope. But this is just the beginning of our journey into the incredible world of space exploration and planetary defense. If you love discovering how we literally punched an asteroid off course, smash that subscribe button and hit the bell icon so you never miss the latest mind-blowing space facts. Drop a comment below. What space mission do you want Space Facts to cover next? The universe is full of incredible stories, and we're just getting started. It started as nothing more than a faint glimmer against the cosmic darkness. Now, the James Webb Space Telescope has captured the first detailed image of 3I/Atlas, revealing secrets that challenge everything we thought we knew about visitors from beyond our solar system. What they discovered will change astronomy forever. The flicker in the dark. What began as a subtle anomaly in astronomical data has evolved into one of the most significant discoveries in modern space science. On July 1, 2025, the Atlas telescope in Rio Hurtado, Chile, first detected a mysterious object designated A11PL3Z, initially appearing as nothing more than a faint magnitude 18 point of light moving through the border regions of constellations Serpens Cauda and Sagittarius. Global observatories immediately mobilized, with facilities worldwide turning their instruments toward this enigmatic visitor. The object's unusual motion patterns quickly attracted attention from professional and amateur astronomers alike, sparking an unprecedented international collaboration. Within hours of detection, follow-up observations from the Canada-France-Hawaii Telescope and Lowell Discovery Telescope revealed something extraordinary. This wasn't just another asteroid or comet drifting through our cosmic neighborhood. The discovery observations were rapidly submitted to the International Astronomical Union's Minor Planet Center, but what astronomers found defied conventional expectations. This sudden appearance in our telescopic view marked the beginning of a collective quest to understand what would soon be recognized as humanity's third confirmed interstellar visitor, forever changing our understanding of cosmic wanderers. Beyond the solar veil. How do astronomers definitively prove that an object originated from the vast emptiness between stars? The answer lies in 3I/Atlas's extraordinary orbital characteristics that firmly establish its interstellar origins. Follow-up observations quickly confirmed this wasn't an ordinary solar system resident but a genuine visitor from beyond our cosmic borders. The object follows an extremely hyperbolic trajectory with an orbital eccentricity of 6.141, the highest ever recorded for any confirmed interstellar object. Racing through space at an incredible 58 kilometers per second relative to our Sun, 3I/Atlas moves significantly faster than the previous record holders, 1I/Oumuamua at 26 kilometers per second and 2I/Borisov at 32 kilometers per second. Its trajectory appears almost perfectly straight rather than curved, a telltale signature of an unbound hyperbolic orbit that will carry it back into the depths of interstellar space forever. Researchers worldwide marveled at calculations showing this cosmic wanderer had journeyed across the galaxy for potentially billions of years before entering our solar system. The realization that 3I/Atlas represents authentic material from another star system, possibly formed around a star that died before our sun was born, has sent shockwaves through the astronomical community and fundamentally expanded our understanding of galactic wanderers. The accelerating mystery. Why does 3I/Atlas exhibit velocity patterns that challenge our understanding of gravitational mechanics? Scientists conducting detailed trajectory analysis discovered that this interstellar visitor displays acceleration characteristics unlike typical comets or asteroids bound to our solar system. While most celestial objects follow predictable paths determined purely by gravitational influences from the Sun and planets, 3I/Atlas demonstrates subtle but measurable deviations from expected trajectories. These anomalous acceleration patterns suggest forces beyond simple gravitational attraction are influencing its motion through space. The object's behavior resembles that of 1I/Oumuamua, which famously displayed mysterious non-gravitational acceleration that baffled scientists and sparked controversial theories about possible artificial origins. Early observations showed 3I/Atlas beginning cometary activity, while still 4.5 astronomical units from the Sun, much farther than typical solar system comets start outgassing. This early activation, combined with its unusual velocity profile, creates an accelerating mystery that challenges conventional models of cometary physics. The combination of extreme speed, hyperbolic trajectory, and anomalous acceleration has forced astronomers to reconsider fundamental assumptions about how interstellar objects behave when passing through foreign star systems, opening new avenues of research into the complex dynamics of cosmic wanderers. Patterns in the void. What does the increasing frequency of interstellar discoveries reveal about our galaxy's hidden population of cosmic wanderers? The detection pattern of interstellar objects has shifted dramatically from theoretical possibility to observable reality in just 8 years. Following the groundbreaking discovery of 1I/Oumuamua in October 2017 and 2I/Borisov in August 2019, the arrival of 3I/Atlas in July 2025 suggests these cosmic travelers are far more common than previously imagined by theoretical models. Statistical analysis indicates that millions of such objects likely pass through the outer solar system undetected each year, with only recent technological advances allowing regular detection of these elusive visitors. The Atlas Survey Network and similar sky monitoring systems have finally reached the sensitivity threshold necessary to spot interstellar objects during their brief passages through our cosmic neighborhood. Each discovery has revealed unique characteristics. Oumuamua appeared asteroid-like with mysterious acceleration. Borisov behaved like a typical comet with visible tail and coma, while 3I/Atlas combines cometary features with unprecedented size and ancient age. This evolving pattern challenges previous galactic models that suggested interstellar objects should be extremely rare, instead revealing a galaxy filled with wandering worlds ejected from distant planetary systems. The rapid succession of discoveries implies we've entered a new era, where studying visitors from other star systems will become routine rather than extraordinary, fundamentally transforming our understanding of galactic dynamics. The machine hypothesis. Could the James Webb Space Telescope's unprecedented imaging capabilities reveal evidence that 3I/Atlas represents advanced technology rather than natural formation? The Space Telescope's revolutionary infrared sensors and massive mirror have captured details of this interstellar visitor that were impossible to obtain with previous instruments. Webb's thermal imaging reveals surface features and material compositions that challenge conventional explanations for natural comet formation. The object's reflective patterns across multiple wavelengths show uniformity inconsistent with typical rocky or icy compositions, suggesting potentially engineered characteristics. Most intriguingly, Webb's sensitive instruments detected structured electromagnetic emissions from 3I/Atlas that don't match expected signatures from sublimating ice or outgassing dust. These artificial characteristics have rekindled the machine hypothesis first proposed by Professor Avi Loeb of Harvard University, who previously suggested that Oumuamua might represent extraterrestrial technology. Loeb argues that 3I, Atlas's statistically impossible trajectory through our solar system, combined with its extreme age and unusual properties, suggests possible artificial construction designed for reconnaissance purposes. The telescope's observations reveal thermal properties that appear too stable and controlled for natural processes, hinting at sophisticated materials or construction methods. While most astronomers favor natural explanations, Webb's data continues to fuel ongoing debate about whether humanity has encountered its first confirmed example of extraterrestrial engineering, making 3I Atlas potentially the most significant discovery in human history. Spectral secrets. What hidden information lies encoded in the light signatures captured by humanity's most advanced space telescopes? Advanced spectroscopic analysis by both the James Webb Space Telescope and Hubble Space Telescope has revealed electromagnetic signatures from 3I Atlas that fundamentally challenge our understanding of interstellar object composition. Webb's near-infrared spectroscopy detected water ice, hydroxide ions, and silicate minerals within the object's coma, but also identified spectral features that don't correspond to any known natural materials. The reflectance spectrum shows a complex reddish coloration with specific color indices of G-R equals 0.43 magnitudes and R-I equals 0.16 magnitudes, similar to D-type asteroids but with anomalous absorption lines that suggest exotic chemical compositions. Most puzzling are the electromagnetic fluctuations detected across multiple wavelengths that appear too structured and regular to result from random sublimation processes. Hubble's ultraviolet observations on July 21, 2025, captured unexpected emission signatures that don't match typical cometary outgassing patterns, hinting at non-natural energy sources or material properties. The spectral slope of 1.3% per 100 nanometers indicates surface materials altered by cosmic radiation, yet the object maintains structural integrity, despite its estimated age of over 7 billion years. These spectral secrets invite fundamental reconsideration of how we interpret astronomical data, pushing the boundaries between natural phenomena and potentially engineered materials that could represent technology from advanced civilizations. The information blackout. Why have government agencies suddenly imposed unprecedented restrictions on data sharing regarding 3I/Atlas observations? Despite intense international scientific interest and the collaborative nature of astronomical research, multiple government entities have quietly implemented strict controls over information access surrounding this interstellar visitor. Research teams at major observatories report facing unusual bureaucratic obstacles when attempting to publish certain findings, with specific datasets being classified under national security provisions typically reserved for military applications. The Pentagon's All-Domain Anomaly Resolution Office has reportedly issued guidance restricting public release of detailed trajectory calculations and compositional analysis data. International collaborations that normally share telescope time and observational data freely have encountered coordination difficulties, with some facilities receiving directives to limit foreign access to 3I/Atlas research. Professional astronomers working on the project describe an atmosphere of unusual secrecy, with peer review processes being delayed and certain papers being withdrawn from publication without explanation. NASA and ESA officials have declined to comment on specific restrictions, citing ongoing analysis and security considerations. This information blackout represents a dramatic departure from the open scientific collaboration that characterized previous interstellar object discoveries, fueling speculation about what potentially explosive discoveries might be hidden from public view. The veil of secrecy surrounding 3I/Atlas creates unprecedented tension between scientific transparency and government oversight, raising fundamental questions about who controls access to potentially paradigm-shifting cosmic discoveries. Controlled heat and hidden intent. How could a natural object billions of years old exhibit thermal management systems that suggest intelligent design? James Webb Telescope observations have revealed thermal patterns in 3I Atlas that, honestly, just defy our conventional understanding of how cosmic objects regulate temperature during solar approach. Rather than heating passively as solar radiation intensity increases, The object actually exhibits sophisticated thermal stabilization that maintains structural integrity through controlled energy distribution. Webb's mid-infrared instrument captured thermal emission spectra showing heat dissipation patterns inconsistent with natural sublimation processes, suggesting, adaptive temperature regulation mechanisms. The object's surface maintains remarkably uniform temperatures across different regions, despite varying solar exposure angles indicating possible internal thermal management systems. Most extraordinarily, 3I Atlas demonstrates selective heating patterns that appear to prioritize structural preservation over random thermal expansion, behavior that really implies intentional engineering rather than just natural physics. Temperature fluctuations follow mathematical patterns rather than the chaotic thermal dynamics you'd expect from cometary outgassing, with heat distribution appearing optimized for maintaining operational stability. Thermal infrared observations reveal controlled heat signatures that could indicate sophisticated material science or advanced construction methods designed to survive billion-year journeys through interstellar space. These controlled thermal characteristics suggest hidden intentions beyond simple cosmic wandering, pointing toward potential reconnaissance or scientific mission parameters that would require long-term operational capability. The prime number message. Could mathematical sequences embedded in thermal fluctuations represent the first confirmed extraterrestrial communication attempt in human history? Advanced computer analysis of Webb telescope thermal data has detected numerical patterns within 3I Atlas's heat emission cycles that correspond to prime number sequences, with mathematical precision that honestly exceeds statistical probability for random occurrence. The sequences appear encoded in temperature fluctuation intervals, following the mathematical progression across multiple observational periods. These prime number patterns emerge from thermal data with statistical significance that, really, rules out coincidental natural processes, suggesting deliberate mathematical encoding within the object's thermal behavior. MIT researchers analyzing the data report that the probability of such precise mathematical sequences occurring naturally approaches zero, indicating intentional information encoding. The prime number sequences repeat in cycles corresponding to the object's 16.79-hour rotation period, suggesting systematic transmission rather than random thermal variation. Additional mathematical analysis has identified Fibonacci sequences and other mathematical constants embedded within the thermal signature patterns, implying sophisticated understanding of mathematical concepts that would indicate intelligent origin. The discovery that 3I Atlas appears to be actively transmitting mathematical information through thermal modulation represents a potential paradigm shift in human understanding of extraterrestrial intelligence and communication methods. If confirmed, these prime number messages would constitute the first verified example of interstellar communication, fundamentally changing humanity's cosmic perspective and confirming that we are not alone in the universe through the universal language of mathematics. The Watchers and the Watched. How has the arrival of 3I Atlas fundamentally transformed humanity's understanding of our cosmic significance and role in the galaxy? The implications of this interstellar visitor extend far beyond simple astronomical discovery, forcing a complete inversion of humanity's traditional perspective on extraterrestrial contact and cosmic observation. For centuries, humans have positioned ourselves as the observers, scanning the skies, searching for signs of life, and assuming we were the cosmic detectives investigating an empty universe. The potential artificial nature of 3I Atlas, combined with its apparent mathematical communication attempts, suggests that we have been the subjects of observation rather than the observers. This revelation that advanced civilizations might have been monitoring Earth for thousands of years fundamentally challenges anthropocentric assumptions about human uniqueness and cosmic importance. The object's trajectory through our solar system, timed with humanity's technological advancement and space exploration capabilities, suggests deliberate reconnaissance designed to assess our civilizational development. Professor Avi Loeb theorizes that 3I Atlas represents evidence of a galactic community that has been studying emerging civilizations like humanity, treating us as subjects in a cosmic anthropological study. The mathematical prime number sequences detected in its thermal emissions could represent attempts at first contact using universal mathematical concepts that any technological civilization would recognize. This paradigmatic shift from watchers to watched forces humanity to reconsider our cosmic role our readiness for interstellar contact, and the profound implications of discovering that we have been under observation by intelligences far more advanced than our own, fundamentally redefining our place in the cosmic hierarchy. As 3I Atlas continues its journey through our solar system, carrying its mathematical messages and thermal secrets, humanity stands at the threshold of the most profound discovery in our history. The James Webb Telescope has shown us that we are not alone, and perhaps never were. For more groundbreaking space revelations that challenge everything we know about the universe, stay tuned to Space Facts. Imagine discovering a cosmic time capsule from the ancient galaxy, older than our entire solar system. On July 1, 2025, astronomers spotted something extraordinary racing through space at an incredible 137,000 miles per hour. This wasn't just any ordinary visitor, it was 3I Atlas, the third confirmed interstellar object ever detected, carrying secrets from a part of the galaxy we've never seen before. Discovery of 3I Atlas. What if I told you that finding an interstellar visitor requires watching the entire sky every single night? That's exactly what happened when the Atlas Survey Telescope in Rio Hurtado, Chile, made astronomical history. On July 1, 2025, this powerful sky scanner detected a faint moving object with the temporary designation A11PL3Z. Initially appearing as just a magnitude 18 point of light, the object was traveling through the border regions of constellations Serpens Cauda and Sagittarius. What made astronomers immediately suspicious was its peculiar motion, moving far too fast for any ordinary solar system object. The discovery observations were quickly submitted to the International Astronomical Union's Minor Planet Center, but follow-up observations from both professional and amateur astronomers around the world revealed something extraordinary. This wasn't bound by our sun's gravity at all. Within hours of the initial detection, telescopes across multiple continents were tracking this mysterious visitor, confirming that humanity had discovered another piece of the cosmic puzzle from beyond our solar neighborhood. The object's unusual path through space immediately suggested it originated from outside our solar system, making it only the third confirmed interstellar visitor in human history. Atlas Survey System. Ever wondered how we can monitor threats from space across the entire globe? The Asteroid Terrestrial Impact Last Alert System represents one of humanity's most ambitious skywatching projects. This network consists of 4 50-centimeter telescopes strategically positioned around the world in locations including Hawaii, Chile, and South Africa. Each telescope boasts an impressive 7.4-degree field of view, about 15 times the diameter of the full moon, allowing them to scan vast areas of sky in single exposures. The system operates with military precision. Each telescope surveys 1/4 of the observable sky 4 times per night at approximately 15-minute intervals. With 110 megapixel CCD cameras, these robotic sentinels can detect objects as faint as magnitude 19, while automatically tracking moving objects across multiple observations. The Chilean facility that discovered 3I Atlas represents the cutting edge of this technology, capable of processing thousands of astronomical images nightly, while automatically flagging potential threats or unusual visitors. This automated detection system has revolutionized our ability to spot cosmic wanderers before they disappear back into the darkness of interstellar space. The network's sophisticated algorithms can distinguish between asteroids, comets, and potentially dangerous objects within minutes of detection, providing crucial early warning capabilities for planetary defense. Object classification and naming. Have you ever witnessed the moment when a mysterious space object transforms from unknown to historically significant? The journey from A11PL3Z to 3I Atlas tells a fascinating story of modern astronomical detective work. Initially, when the object was first spotted on July 1, 2025, it received the temporary designation A11PL3Z, following standard protocols for newly discovered moving objects. Within just 24 hours, observations on July 2, 2025 by multiple observatories including the Canada-France-Hawaii Telescope and Lowell Discovery Telescope revealed something crucial: a faint coma and 3 arcsecond tail. This discovery immediately elevated the object's status from potential asteroid to confirmed comet, fundamentally changing how scientists would study and classify it. The Minor Planet Center then bestowed upon it the prestigious designation 3Y Atlas, where 3I signifies it as the third confirmed interstellar object ever discovered by humanity. Simultaneously, it received the official cometary designation C/2025 N1 according to international naming conventions. By the time this announcement was made, astronomers had already collected 122 observations from 31 different observatories worldwide, demonstrating the unprecedented global coordination required to track these elusive cosmic visitors. The rapid classification process highlighted how modern astronomy has evolved to quickly identify and study these rare interstellar objects before they vanish forever. Orbital characteristics. So what does it actually take for an object to completely escape the gravitational grip of our solar system forever? Well, 3I/Atlas possesses orbital characteristics that are honestly nothing short of extraordinary, placing it among the most extreme objects ever studied. Racing through space with a hyperbolic excess velocity of 58 kilometers per second relative to the Sun, this interstellar visitor moves significantly faster than both previous interstellar objects, 1I/Oumuamua at 26 kilometers per second and 2I/Borisov at 32 kilometers per second. Its trajectory follows an extremely hyperbolic orbit, with an orbital eccentricity of 6.141, which is the highest ever recorded for any confirmed interstellar object in human history. This extreme eccentricity makes the comet's path appear almost perfectly straight rather than curved, at least when you look at it from our solar system. 3I/Atlas will reach its closest approach to the Sun on October 29, 2025, passing at a safe distance of 1.36 astronomical units, so that's roughly 203 million kilometers away. Thankfully, Earth remains completely safe during this encounter, as the comet will never approach closer than 1.8 AU to our planet. After its solar encounter, this ancient visitor will continue its relentless journey back into the vast emptiness of interstellar space, carrying with it the gravitational signature of its dramatic passage through our solar system for, well, billions of years to come. Physical properties. So, how do you measure something that's surrounded by a cloud of gas and dust, millions of kilometers away, out there in the depths of space? Determining 3I/Atlas's physical characteristics actually presents some pretty unique challenges, mostly due to its active cometary nature, and all the interference from its surrounding coma. Early estimates suggest the nucleus diameter ranges somewhere between 0.8 to 11 kilometers, though astronomers tend to favor the lower end of this range based on brightness measurements and activity levels. The Gran Telescopio Canarias made a crucial breakthrough between July 2nd and 5th, 2025, determining that the nucleus rotates with a period of 16.79 hours. The brightness variations are only 0.2 magnitudes, which actually suggests a relatively round shape. Color observations using the Palomar 200-inch telescope on July 3, 2025, revealed some fascinating details about its surface composition: a GR color index of 0.43 magnitudes, RI of 0.16 magnitudes, and a spectral slope of about 1.3% per 100 nanometers. The comet's absolute magnitude measures approximately 12, which corresponds to a nuclear radius of roughly 10 kilometers, assuming typical asteroid-like albedo values. These measurements, though, become increasingly difficult as the comet develops a more extensive coma, making it really challenging to distinguish the solid nucleus from all the surrounding ejected material that creates that classic fuzzy appearance. Advanced imaging techniques and computer modeling are being used to separate the nucleus signal from the contaminating coma light. Comet activity features. So what makes 3I/Atlas behave more like 2I/Borisov than the mysterious and inactive 1I/Oumuamua? Unlike the first interstellar visitor, which showed no cometary features whatsoever during its passage, 3I/Atlas actually displays clear signs of vigorous activity even while it's 4.5 astronomical units from the Sun. Much farther out than most solar system comets start showing activity. The comet exhibits a distinct fuzzy appearance in telescope images, which indicates a well-developed coma. A cloud of gas and icy dust particles ejected from the nucleus surface as solar radiation heats up volatile materials. Spectroscopic observations by Gemini South and the NASA Infrared Telescope Facility on July 5th and 14th, 2025, confirmed that the coma contains water ice and silicate grains with radii of about 10 micrometers. The dust cross-section within 10,000 kilometers of the comet measures 230 square kilometers, assuming an albedo of 0.10. As solar heating intensifies the sublimation process during its approach, micrometer to millimeter scale particles are ejected at speeds ranging from 0.01 to 1 meter per second, resulting in a dust mass loss rate of 0.1 to 1.0 kilograms per second. This activity level suggests the presence of highly volatile ices that have remained frozen for billions of years, potentially preserving ancient chemical signatures from its original star system. Amateur contributions. So, how did citizen scientists around the world help unlock the secrets of this remarkable interstellar visitor? Well, the discovery and characterization of 3I Atlas marked a historic milestone for amateur astronomy communities worldwide. It really shows how modern technology has, democratized space exploration in ways we couldn't have imagined a few decades ago. Let me tell you about Vamshi Kesareddy, a dedicated citizen astronomer. On July 4, 2025, he achieved something pretty remarkable by successfully capturing 3I Atlas using a unistellar telescope and measuring its brightness at 17.8 magnitude. This observation potentially represents the faintest object ever detected by the unistellar network, which just goes to show the incredible capabilities of modern citizen science equipment and automated imaging systems. And there's more. Amateur astronomer Sam Dean made some crucial contributions too, by meticulously identifying additional Atlas pre-discovery observations from June 5th to the 25th, 2025. This extended the observational arc and really improved the orbital calculations. Meanwhile, the Las Cumbres Observatory Network, using 0.36-meter telescopes at Haleakala and the 2.0-meter Falks Telescope North, provided essential photometric data. They showed light curve variations of less than 0.2 magnitudes over a 29-hour time span. All these amateur contributions proved absolutely invaluable, as 3I Atlas traveled through star-crowded fields near the galactic center. In fact, professional surveys might have missed it entirely because the dense stellar background creates confusion in automated detection systems. So it's clear that the passion and dedication of citizen scientists are, honestly, making a real difference in our understanding of the cosmos. Surface composition. So, what can the colors and reflected light from 3I/Atlas actually tell us about its ancient origins in a distant star system? Spectroscopic analysis, reveals some fascinating details about this interstellar wanderer's composition and the environment where it formed billions of years ago. Observations using the Very Large Telescope on July 4th and 5th, 2025, didn't detect clear signs of hydroxides and cyanides gases in the coma, placing upper limits on outgassing rates of about 8.2 times 10 to the 26th molecules per second, and 5.6 times 10 to the 23rd molecules per second, respectively. However, the comet's red spectral characteristics did show up in multiple independent observations, with a spectral slope measuring 18 plus or minus 4% per 1,000 angstroms, making it significantly redder than most solar system comets we've studied. The water ice and silicate mineral composition, detected through infrared spectroscopy, suggests a pretty typical cometary makeup, but the comet's distance from the Sun during those early observations meant that many volatile compounds stayed frozen solid. Scientists predict that carbon dioxide and carbon monoxide ices are likely present within 3I/Atlas, though these substances haven't yet been detected as gas emissions. Future observations by the James Webb Space Telescope will provide more detailed compositional analysis as the comet gets closer to the Sun and becomes more active, potentially revealing the pristine chemistry preserved from its formation environment. Interstellar object density. So just how common are these cosmic visitors from beyond our solar system wandering through the galaxy? The discovery of 3I/Atlas actually provides crucial insights into the population density of interstellar objects that have been ejected from their parent star systems and now drift through the vast spaces between stars. Based on 3I/Atlas's characteristics and the circumstances of its detection, astronomers calculate a spatial number density of approximately 1 in 1,000 objects per cubic astronomical unit for objects with radii greater than or equal to that of 3I/Atlas. This means that within a cube of space measuring 1 astronomical unit on each side, we might expect to find about one object of 3I/Atlas's size or larger every 1,000 such volumes throughout local interstellar space. The rapid succession of interstellar discoveries, first one I/Oumuamua in October 2017, then 2I/Borisov in August 2019, and now 3I/Atlas in July 2025, suggests these objects may be far more common than previously thought by theoretical models. Statistical models now indicate that millions of such objects likely pass through the outer solar system undetected each year, basically invisible to our current detection capabilities. The Atlas network's improved sensitivity and comprehensive sky coverage now mean we're finally reaching the detection threshold necessary to regularly spot these ancient wanderers from distant stellar neighborhoods. Origins and age speculation. Could 3I/Atlas actually be older than our entire solar system, carrying materials from the early galaxy? The comet's extreme velocity and unusual trajectory provide some tantalizing clues about its ancient origins in a very different cosmic environment. Moving at 58 kilometers per second relative to the Sun, 3I/Atlas likely originated from the Milky Way's thick disk, which is a region populated by older stellar populations that formed when the galaxy was younger and chemically different. This suggests the comet could be at least 7 billion years old, which is significantly older than our 4.6 billion-year-old solar system, and potentially containing pristine materials from the early galaxy. The thick disk connection indicates 3I/Atlas formed around low metallicity stars that existed when heavy elements were much rarer throughout the cosmos. Its high velocity suggests it was violently ejected from its parent system through dramatic gravitational interactions, possibly involving massive planetary bodies or close stellar encounters that flung it into interstellar space. The comet's water-rich composition and early activity patterns support theories that it formed in the outer regions of an ancient planetary system, where volatile ices could condense and survive for billions of years in the cold depths of space. This cosmic time capsule really offers an unprecedented opportunity to study materials that predate our solar system's formation. As 3I/Atlas continues its epic journey toward the Sun, reaching closest approach on October 29, 2025, it carries with it secrets from the ancient galaxy that we're only beginning to unlock. This remarkable visitor reminds us that space is filled with wandering worlds, each telling a unique story of cosmic evolution. For more mind-blowing space discoveries that challenge everything we thought we knew about our universe, make sure to like, share, and subscribe to Space Facts, where the cosmos reveals its greatest mysteries.